Hello guys, so today we're doing LeetCode question 102, which is binary tree level order traversal. It's a medium question, and the question is, given the root of a binary tree, return the level order traversal of its nodes values. So i.e. from left to right, but level by level. So example 1, the tree has a root node of 3 with a left child node of 9, right child node of 20. The child node of 20 is a left child node of 15 and a right child node of 7. And the output will be 3, an array of 3, with an array of 9 and 20, and another array of 15 and 7. As you can see, it's level by level, left to right. So the first array is the first level, 3. Second array is the second level, 9 and 20. And the third array is the third level, 15 and 7. So example 2, root is 1 and returns an array of 1. Example 3, the root is empty, so it returns an empty array. So let's go over how we do this first. We do this using a breadth first search, which pretty much means an order level by level traversal. So let me show you how we do this. So let's say we have a tree of 1, 2, 3, 4, 5, 6, 7. So we have to use a queue here, and every time we go for a level, we push the item in the queue. So first we go through 1, which is a root node, push that in the queue. Oh, let's go back. This is a comma 1. Oh my, okay. Then you go through child nodes. So as you can see, it's 2 and 3, and you push those in the queue. So 2 and 3. Then you go for those child nodes, which is 4, then 5, then 6, then 7. And that is the level order traversal. This will be level 0, or level 1, then level 2, and then level 3. So these come first, second, and third. Okay, so now let's empty the tree. Back. Keep going back. Alright, so now let me show you how we would do this. So I should let's create a new tree. So we have 1, let's do 2. Well, let's see what the tree is in the LeetCode question. It's 1, 3, 9, 20, 15, 7. Okay, let's do that. 3, 9, 20, 15, and 7. So the first thing we do is create a queue here, and we also create a result here. And in the queue, the first thing we push is the root. So that will be currently 3. So let's put 3 as the root. Now, while the queue is not empty, we loop through its children and we push them to the queue. So the queue is not empty, it's 3. And then we push the queue to the result as well. So we push the root to the result. So the result is now 3 as an array. And then we push the children into the queue. We pop this, push the children into the queue. So now the queue will be 9 and 20. 9 and 20. So we've done this part. This is done. And now again, the queue is not empty. So we'll push in an array these into the result. So now we have an array of 9 and 20. We pop these. Well, first we're going to pop it digit by digit. So let me show you what I mean. Yeah. So first we check the children of 9. And it has none. So we've checked 9 children, so we can pop 9 now. Here, remove it, I mean. And we've done this. Now we check children of 20. So we can see that children has 20 has two child nodes. So we pop 20, add it to the stack. We already have done that. And now we know that Q has 15 and 7, which are the child nodes. Now Q is not empty again. We've done 20. We look for the child nodes. We look for 15 first. So 15 has no children. So we add that in the value as the array. So here, we add 15. And then we pop it. Now we go through 7. 7 again has no child nodes. We do that. That's done. We pop it and add it to the result. So now 15 and 7. And now that Q is not empty, Q is empty, the while loop stops, and this is the result. The order traversal. So order traversal. Breadth first search. So level by level 3, second level, third level. So let me show you how it's done by code. Okay, so let's write the code. So as you can see here, if the root is empty or there's no root, we return empty array. So let's create that base case. So if no root, we return empty array. Now we create a queue, and as we mentioned, the first value in the queue has to be the root. So we can, without the root, the while loop will never iterate because the queue will be empty. Then create a result array, which is an empty array. So now we iterate through the length of the queue as long as it is bigger than 0. Now we have to save the length of the queue to iterate through each value for each node and check the children. So we save the length as let length is equal to queue.length. Now we're gonna have to add each value of the queue into the result. So because the result has to store all the node values in the tree. So let's do result.push. So for each value in the result, in the queue, sorry, we push its value. So let's say node.value. So queue.map for each node, we push its value. Now we have to iterate through each node in the queue as long as it's bigger than 0. So when there's no nodes, we've finished that. And so we get the first value in the queue by shifting it. So queue.shift. Now we have to check if this node has a left value or a right value, and so we push it in the queue. Again, if it has a right value as well, we push that in the queue. Right. Sorry. Alright. Then we decrement the length here, seeing how we've gone through one of the nodes. And yep. Now we return the result. Return the result. Let's see. Let's run. See that passes. Let's submit. See if it passes everything. As you can see, it's one of the fastest methods. This is a time complexity of on again, as we're looping through the tree once. And a space complexity of on, as worst case here, or no, not worst case, as we will store the whole tree in the result. Thanks for watching.